Yes, good afternoon to all of you. Screen is visible. Yes, screen is visible, all of you.
Yes, sir.
Okay, thank you. So yesterday what we have discussed, operating in principle of the three-phase induction motor. Concept is clear yesterday?
Yes, sir.
Okay.
Yes.
So I think you can easily understand the operating principle from this diagram. This diagram is very easy to remember the operating in principle of the three-phase induction motor. Okay, step by step procedure. Next. So today we will see the some small analysis, important equations. Okay, so what is the formula for finding the synchronous speed? What is the formula? What is the equation for finding the synchronous speed? Ns is equal to
120 on P.
120 F upon by P. Is it clear? So this is the formula for finding the synchronous speed. Ns is equal to 120 F upon by P. This is the basic equation. This is in rotations per minute. Rotations per minute. If you want to find out the synchronous speed in rotations per second, एक सेकंड में कितना रोटेशंस मोटर का, तो फाइंड आउट करना तो स्मॉल ns that is represented by small ns that is equal to 2 into f upon by p. That is the rps, rotations per second. Okay, so if you want to convert this rotations per second into minutes, rotation per minute, just 2 into 60 करना, क्योंकि एक मिनट में कितना सेकेंड से 60 seconds, that is equal to 2 into 60 into f upon by p, that is equal to 120 f upon by p in rotations per minute. So like the same way, if you want to find out the synchronous speed in radians per second, so we know that is radians per second is represented by omega s. Omega s is equal to 4 pi f upon by t. Okay, this is the formula for finding the synchronous speed in radians per second. Clear? Or omega is nothing but supply frequency in radians per second. Next, what is the formula for slip? What is the formula for slip? S is equal to ns minus nr upon by ns Okay, just revise all the equations. Slip S is equal to ns minus nr upon by ns. Also, we can write, if you want to write this equation rotations per second, so we can write in small ns minus small nr upon by small ns. Okay, also we can write this equation in radians per second, omega s minus omega r upon by omega s in. Okay, so these are the formulas for finding the sleep. Clear? So how we can find out the motor speed? How we can find out the motor speed? So from this equation, how we can find out? Okay, you know the formula, ns is equal to ns minus nr upon by ns. Sorry, s is equal to s is equal to ns minus nr upon by. Okay, from this equation, how we can find out the motor speed? So we need to find the motor speed, that is equal to ns minus nr is equal to s into ns, s into ns. Clear? So from this equation, what we can write, nr is equal to ns minus s into ns. Can we write like this? From this equation, can we write nr is equal to ns into ns minus s into ns? Anyone?
Yes, sir.
Okay, so from that equation, what we can write, nr is equal to, from this equation, ns common hai. If we can take the ns common, ns into 1 minus s, nr is equal to ns into 1 minus s. Clear? This is the formula for finding the motor speed. Clear? Next, what is the frequency of the motor under running condition? Can anyone tell? What is the frequency of the motor under the running condition? Frequency of the motor, frequency of the rotor circuit or motor, whatever. Okay, so how we can write? It's a very important equation, the relation between the supply frequency and the rotor frequency. Okay, it's a very important question. So what is the relation between the supply frequency and the rotor frequency? Generally, we know the formula, ns is equal to 120 f upon by p. Okay, ns is equal to 120 into f upon by p. So f is nothing but supply frequency or stator frequency also can be called. Okay, because supply is given to the stator circuit. Okay, so from this equation, supply frequency is equal to f is equal to p into ns upon by 120. P into ns upon by 120. Okay, here we have to consider two cases. One is the standstill condition and second one is the running condition. Clear? So under the standstill condition means initial condition. Initial condition में क्या होता है? Motor speed is equal to 0. Motor speed is equal to 0. Is it clear? Motor speed is equal to 0. So that is equal to what will be the slip? So this equation can be right P into ns minus 0 by ns divided by 120. Can we write like this equation under the standstill condition? So under the standstill condition means initial condition. Initial condition means starting condition. Starting condition में क्या होता है? Motor speed is 0. Starting में 0 से start होगा ना कोई भी. अगर if you want to run, so 0 speed से run करना पड़ता है. Okay, start करना पड़ेगा. So like this way, so under the standstill condition, the motor speed is 0, nr is equal to 0. So this equation can be right P into ns minus 0 by ns. Okay, so this equation can be right. This equation can be right P into ns upon by ns in by 120. So like this way, second condition, this is the first case. In second condition, motor is running at the some speed. Okay, under the running condition means motor is running at with some speed. Okay, so अगर motor some speed से run होता है तो motor speed is not equal to 0. nr is not equal to 0. Clear? So in this case, what will be the rotor frequency? Same as from this equation. From this equation, fr is equal to P into ns by P into ns minus nr here, because motor speed is present. P into ns minus nr upon by ns divided by 120 divided by 120. It is clear? So from this equation and from this equation, so we can write here fr upon by f. Okay, f, we know the formula. We know the formula f. What is the formula of f? What is the formula of f? Stator frequency. Stator frequency formula क्या है? Can anyone tell? What is the stator frequency formula? It is in green line.
P divided by 120.
P into ns upon by ns into 120. Okay, ns can be cancelled. Later we will see. Okay, so here also what we can write here, rotor frequency we are having formula. Okay, so substitute in this equation. What is therefore P into ns minus nr upon by ns divided by 120. Okay, so whole divided by मैं कैसे ऐसे करूँ क्या? ऐसे करूँ?
Yes, sir.
Okay, स्क्रीन कम पड़ रहा है. P into ns by ns whole divided by 120. So here 120 will be cancelled. 120 will be cancelled. P will be cancelled. ns will be cancelled. So बचा क्या आपको? ns minus nr upon by remaining term is ns minus nr upon by this term ns. Clear? Means fr rotor frequency by stator frequency is equal to ns minus nr upon by ns. So what we can write ns minus nr upon by ns? What we can write? This is slip na. ns minus nr upon by ns is nothing but slip na. Is it right? Yes. Yes, is slip na.
Yes, sir.
Okay. So from this equation, what we can write? Fr by f is equal to s. So from this equation, fr is equal to s into f. This is the relation between the rotor frequency and stator frequency. Okay. Fr is equal to slip times of the stator frequency. Clear? Okay, that's why here what we have written. यहाँ पे directly दिया मैंने, so वहाँ पे थोड़ा सा explain किया. Next, rotor EMF, same concept. Okay, whatever we have derived the equation for rotor frequency, it will be applicable for all the quantities. Okay, here also same way. So induced EMF of the rotor circuit under the running condition E2R is equal to S into E2. S into E2. So here E2R is nothing but what? And E2 is nothing but what? E2 is nothing but induced EMF. Okay. So induced EMF on the running condition, induced EMF for the standstill condition. E2 is nothing but induced EMF of the rotor circuit of the standstill condition and induced EMF of the rotor circuit under the running condition. Clear? So same as previous equation, also we can write E2R is equal to S into E2. E2R is equal to S into E2. Induced EMF of the rotor circuit is equal to slip times of the rotor EMF for the standstill condition. Okay, so let the rotor resistance per phase under standstill condition. R2 is nothing but rotor resistance per phase under the standstill condition. Okay. Next, X2 is nothing but rotor reactance per phase under the standstill condition. So यहाँ पर per phase क्यों लिया? Because this is the 3-phase induction motor. So एक phase का एक quantity लेते हैं. Clear? That's why we are taking the per phase values. X2 is nothing but here not X into 2. That is nothing but X like this. Okay. Here R2 is nothing but R suffix 2. So please don't get any confusion. So next, X2 is equal to 2 pi. We know the formula reactance X is equal to 2 pi FL. Reactance is X is equal to 2 pi FL. Okay. So LT is equal to inductance per phase of the rotor. Z2 is equal to, we know the formula, Z2 square is equal to impedance resistance square plus rho resistance plus reactance square. R2 square plus X2 square. Okay, Z2 square is equal to, sorry, Z2 is equal to, from this equation Z2 is equal to square root of R2 square plus X2 square. So rotor current, directly we have written the equations. Okay, so rotor current I2 is equal to E2 upon by Z2. So why we have written the E2 upon by Z2? Because current is equal to voltage upon by impedance. So can we write V is equal to IZ? V is equal to IZ or E is equal to IZ. So I is equal to what we can say E by Z. Clear? So like this way we can write the rotor current I2 is equal to E2 upon by Z2. E2 upon by Z2. Rotor power factor cos phi 2 is equal to the ratio between the rotor resistance to the impedance of the rotor circuit. So now in running condition, we know the formula E2R is equal to S into E2. Okay, running condition में ये वाला E2R is equal to S into E2. Rotor reactance per phase under the running condition. Okay, so X2R is equal to running condition में ये भी changes हो जाएगा. X2R is equal to slip times of the rotor reactance under the standstill condition. जैसे अपन लिखा था FR is equal to S into F. FR is equal to S into F. So based on this equation, we can write the E2R is equal to S into E2, X2R is equal to S into X2. Okay, X2 is nothing but reactance, that is equal to 2 pi F L. Okay, यहाँ पे S भी आएगा. Next, rotor impedance per phase Z2R is equal to R2 square plus S into X2 square. Here the rotor resistance will not be changes under this standstill or running condition. Okay, so that's why it is the same. Z2R is equal to square root of R2 square plus S into X2 square. S into X2 square. So cos phi 2R is equal to power factor under the running condition. Power factor under the running condition. यहाँ पे क्या लिखा? Power factor the standstill condition. Now we are checking the running condition. So power factor is equal to running I2R is equal to S into E2 upon by Z2R, that is equal to, so यहाँ पर क्या लिखा है? R2 by Z2. So यहाँ पर क्या लिख सकते हैं अपन? Running condition पे R2 upon by Z2R. Z2R. This is called as the rotor power factor. Okay, that is equal to cos phi 2R. cos phi 2 क्यों लिखा है? रोटर पावर फैक्टर. ओके, सो R क्यों लिखा है? रनिंग कंडीशन. ओके, यहाँ पर R नहीं लिखा है. वी हैव नॉट रिटर्न द R हियर बिकॉज इट इज अ स्टैंड स्टिल कंडीशन. सो लाइक दिस वे यू हैव टू अंडरस्टैंड. So like this way, rotor current under the running condition is equal to rotor current under the running condition. So generally we know the formula E2 by Z. E2 upon by, so E2R upon by Z2R. But here E2R is nothing but running condition में क्या होता है? E2R is equal to S into E2. S into E2 upon by Z2R. Clear? So we can substitute in this equation. S into E2 upon by Z2R is nothing but square root of R2 square plus S into X2 whole square. Okay, so here we have written the rotor power factor under the running condition like this. Okay, so note that the electrical frequency of the induced negative sequence current in the rotor is obtained as, okay, electrical frequency when the negative sequence current in the rotor circuit. Negative sequence means क्या होता है? Slip is negative. So उस केस में क्या होता है? F is equal to, F means electrical frequency of the induced negative sequence. So that can be represented by anything. So now we have represented by F0, that is equal to 2 minus S into 2 minus S into F. Okay, 2 minus S into F. Minus S क्यों लिखी? Because negative sequence. Okay, negative sequence current. Negative sequence means current is negative. Current negative हो तो slip automatically negative हो जाता. Clear? So this numerical we have solved yesterday. So here, see the one small example. A 4-pole induction motor. A 4-pole induction motor supplied by slightly unbalanced 3-phase 50 Hz source, slightly unbalanced. Okay, so is rotating at 1440 rpm. The electrical frequency in hertz of the induced negative sequence current in the rotor is, so we have given the formula. This is the formula. F0 is equal to 2 minus S into F. So we can use that formula. F0 is equal to, what is that? Frequency, electrical frequency of the induced negative sequence current. F0 is equal to 2 minus S into F. This is the shortcut. Okay, 2 minus S into F. So F is nothing but how much he has given. Supply frequency is 50 hertz. That is equal to 2 minus S is nothing but here slip. 2 minus S into 50 hertz. 2 minus S into 50 hertz. So, but we do here he has given any slip value. He has not given any slip value. So we need to find the slip. S is equal to what is the formula? Ns minus Nr upon by Ns. Ns is nothing but here. How much Ns? Ns मालूम है क्या? Ns also we don't know the value of Ns. We know the value of Ns. Ns minus Nr upon by Ns. But here we know the value of Nr because he has given the 1440 rpm motor speed or rotor speed, but he has not given the synchronous speed. So synchronous speed we can easily find out. Ns is equal to 120 into F upon by P. Ns is equal to 120 into F upon by P. So that is equal to 120 into F. Frequency दिया है 50 hertz. 120 into 50 divided by 4. How much this one? 1500
RPM.
1500 na?
Yes, sir.
Okay. 4 3s into 20. 3 into 50, 1500. Sorry, 30 ke? Check it one. I don't know. 15. So substitute in this equation. 1500 minus यहाँ पे लिखा है, इधर सॉल्व किया है, और नेक्स्ट स्लिप कितना है अपन को? 1500 minus 1440 divided by 15, that is equal to 0.04. That is equal to 0.04. So that is equal to what we can write here? 2 minus 0.04 into 1500. So value is equal to 98 hertz. What is the value of this one? What is the value of this one? 2 minus 0.04 into 1500. That is equal to 98 hertz. So answer is the B. So means यहाँ पे क्या याद रखने का है? Whenever we are getting the statement electrical frequency in hertz of the induced negative sequence current, just directly we have to use this formula: 2 minus S into F. 2 minus S into F. Clear? So every time we will not get the shortcuts. Next, the slip of induction motor is normally does not depend on the rotor speed, synchronous speed, shaft torque, core loss component. यहाँ पे अपन को मालूम है फॉर्मूला S is equal to Ns minus Nr upon by Ns. Is it clear? The slip of induction motor normally does not depend. यहाँ slip किस पे depend है? Synchronous speed पे depend है और rotor motor speed पे भी depend है. Depend है कि नहीं? So rotor speed is wrong answer and synchronous speed is wrong answer. Does not depend. किस में depend नहीं होता है? नेक्स्ट दो आंसर कौन सा बचा है, शॉफ्ट टॉर्क एंड क्रॉस लॉस कोर लॉस कंपोनेंट। जनरली अपन को ये शॉफ्ट टॉर्क इज डिपेंड्स अपॉन द स्लिप, टॉर्क इज डिपेंड्स अपॉन द स्लिप ना, अगर स्लिप वेरी हो गए तो टॉर्क भी वेरी होता है। So indirectly the slip is depends upon the shaft torque also, or shaft torque is indirectly depends upon the slip also. So this is also wrong answer. So what we can say, so the slip is does not depend on the core loss component. The slip is does not depend on the core loss component. Clear? Next. See here, I have given the solution in this one. A 400 volts, 50 hertz, 4 pole, 1400 RPM star connected squirrel cage induction motor has the following parameters. Refer to the stator. So यहाँ पर क्या होता है, we need to discuss the equivalent circuit of the induction motor, but we have not discussed the equivalent circuit of the induction motor. Discussion किए क्या अभी तक? Discussion kiya ka equivalent circuit of induction motor? No. So tomorrow we will see. So just check this one. RR is equal to rotor resistance is equal to 1.0 ohms. XS is equal to stator reactance is equal to rotor reactance is equal to 1.5 ohms. Okay, neglect the stator resistance and core and rotor rotational losses of the motor. The motor is controlled from three-phase voltage source inverter with V by F control, not V by FE. VF is नहीं हो, V by EF. V by F control. The stator line-to-line voltage RMS and frequency to obtain the maximum torque is. Okay. So what is the answer? So यहाँ पे equations we have not discussed. We will discuss later. What has given the data? Supply voltage 400 volts, frequency 50 hertz, 4 pole, number of poles are the 4, and motor speed is 1400 rpm, star connected squirrel cage induction motor. So resistance कितने दिए इन्होंने, rotor 1.0 ohms. Rotor stator reactance is equal to rotor reactance refer to the rotor side, that is equal to 1.5 ohms. So maximum slip कब present रहता है, when the torque is maximum. Okay, when the torque is maximum at that point, for example this is the torque. Okay, for example अगर ये maximum torque है, so during this point what will be the slip? That slip can be called as a maximum slip. Okay, that slip can be called as a maximum slip. Okay, so Sm is equal to Rr dash upon by XSM plus XRM dash. So these equations are coming from the equivalent circuit of the induction motor. Already, I think this topic has covered by HOD madam previous ATT. Okay, that's why directly I have taken the equations. This one already this topic has covered, I think. So for starting torque, Sm is equal to 1. So obviously, starting torque में Sm is equal to 1 Q. Yes, starting torque में slip क्यों लिया अपन? Starting torque में slip 1 क्यों लिया है? Starting torque S is equal to Ns minus Nr अपन by Ns. So यहाँ पर starting में क्या होता है? Motor speed is 0. Motor speed is 0 means what we can write Ns by Ns. What we can write Ns by Ns. Ns will be cancelled, that is equal to 1. That's why what we can write here, slip is equal to 1. Okay. At starting torque slip is equal to 1. So then xsm plus xrm dash is equal to rr dash. So here x is nothing but 2 pi fl, but it is referred to the stator. So that's why what we can write 2 pi fm into ls plus, this is also 2, not 0.2. So x is equal to 2 pi fl, means this is the refer to the rotor parameters. 2 pi fm into lr dash, that is equal to 1. Okay, 1 cubic rotor resistance is 1. He has given the numerical 1. So that is equal to frequency at maximum torque. Okay, frequency at maximum torque, because all parameters are we are writing with respect to maximum torque. That's why we have written the FM. Frequency at maximum torque FM is equal to 1 by 2 pi into ls plus lr dash. Okay. So from this equation, what we can write? यहाँ पे FM कॉमन है, यहाँ पे FM कॉमन है. So FM is, that is equal to 1 by just wait. So that is equal to, from this equation, what we can write? FM is equal to FM into 2 pi ls plus 2 pi lr dash is equal to 1. Just wait. Okay, so FM is equal to, from this equation, FM is equal to 1 by, यहाँ पे 2 pi common, so we can take the 2 pi common, ls plus lr dash. Okay, so that's why directly we have written this equation. That is equal to, so we can substitute all the values in this one, because we know the values, all values we know. 1.5, x is equal to 1.5 by 2 pi into ls plus lr dash. ls plus lr dash, is there any वहां पे दिए गए ls plus lr dash दिए के, तो फ्रीक्वेंसी इधर लिए अपन, ls को इधर लिए, तो क्या हो जाएगा 1.5 अपन by 2 pi into f. Okay, so same like this way, from this equation एक बार ls को, एक बार lr को, lr is equal to 1.5 अपन by 2 pi into 50. So that is equal to, what we can write here, fm is equal to 1.5 upon by 50 plus 1.5 upon by 50, that is equal to 50 upon by 3, that is equal to 16.7 kilohertz. ये equation analysis करो आप, analyze this equation, so you can get the answer. So next, in constant V by F control method, okay, V by F is equal to 400 by 50. So constant V by F means क्या होता है, V voltage upon by frequency is equal to constant. So that is equal to voltage कितना दिया था 400 upon by F कितना है 50 hertz, that is equal to 8. Okay, so constant V by F. So voltage changes हो गए. For example, initial condition में V voltage is V1 and F1 frequency is F1. So if any voltage and frequency changes, that is also same, because this method is constant. So that is also V2 by F2 is also same. Clear? So that is equal to, what we can write here, V2 is equal to F2 into 8. F2 into 8. So F2 is nothing but here frequency. जो changes हुआ वो frequency 116.7 into 8. 16.7 into 8. That is equal to how much value? 133.3 volts. 133.3 volts. Clear? So 16.7 and 133.3. 16.7 and 133.3. B is the right answer. Just you have to remember these equations only. Clear? Next numerical. Next, what is the next numerical? A three-phase squirrel cage induction motor has starting torque of 150% and maximum torque of 300% with respect to rated torque at rated voltage and rated frequency. A three-phase squirrel cage induction motor has starting torque of 150% and maximum torque of 300%. So screen is visible. 150% and 300%. Okay. Next, respect to rated torque and rated voltage and rated frequency. Neglect the stator resistance rotational losses. The value of slip for maximum torque is. The value of the slip for maximum torque is. So here you can see. Here you can see. Starting torque is equal to 150% of the full load torque. So that is equal to 1.5. So maximum torque 300% of the full load torque. Okay. 300% मतलब कितना होगा? 300 by 100. यही है ना? 3. So means 3 into full load torque. Okay, starting torque is equal to 150% of the full load torque. 150% means 150 divided by 100 means 1.5 into TFL. So maximum torque is 300% of the full load torque, that is T3 into TFL. So what we can write here, TST upon by TF, T maximum. Starting torque upon by T maximum is equal to 1.5 upon by 3. 1.5 upon by 3 is equal to 1 by 2. Okay, 1.5 divided by 3 is equal to 1 by 2. So that is equal to, also we have a formula, TST upon by T maximum is equal to 2S in 2S S maximum divided by S square plus 1 square. So this equation you have to remember. Okay, so this equation we have not derived, but this equation we have to remember. So what is this? Ratio between the starting torque to the maximum torque in terms of slip. In terms of slip, that is equal to 2 into S maximum upon by S square plus 1 square. So here what we can write from this equation, and from this equation, so 1 by 2 is equal to 2 into S maximum, 2 into S maximum upon by S maximum upon by S square plus 1 square, S square plus 1 square. So here you can write S square plus 1 is equal to 2 into 2, 4 into S maximum. Okay, so what we can write here? S square minus 4S maximum plus 1 is equal to 0. This is the algebraic sum equation. So differential equation, second order differential equation. So by solving this equation, we can get the S values. Okay, the 26.786%. 26.786% है किधर 27 786 means 79. Okay, D is the right answer. D is the right answer. Clear? Okay, just wait, I will take the attendance. So what about the other students? Only 39 students have joined. Daily 30 students, 25 students. What about others?